LaFerrari slashes more than 5 seconds off the Enso's lap record at the Fiorano circuit. A huge step forwards where the following factors play a pivotal role: architecture, evolutions in hardware, dampers, brakes and tires, innovative dynamic vehicle control systems which integrate 2 essential new components, the hybrid system and active aerodynamics, with major evolutions in traction control and damping. The car was designed and developed from the very outset with the constant interaction of all of these elements in mind. The hybrid system in particular is constantly activated and, thanks to its various recharging methods, ensures that power is constantly available to improve the car's performance. We will see how this works in greater detail during a lap of the circuit. Take just one example. LaFerrari's peak speed on the straight at Fiorano is 20 km/h faster than the Enso. This dramatic improvement in speed was made possible by the synergic interaction of several different systems. The hybrid system, for instance, releases power to the electric motor, which generates around 150 horsepower, which is then added to around 800 horsepower from the V12. The active aerodynamics adopts a configuration to reduce drag. The rear spoiler lowers. The flaps on the rear diffuser lower. The guide vane on the underbody opens. The flaps on the front diffusers lower. Longitudinal deceleration is improved by 15% thanks to improved braking capacity that is the direct result of the synergic integrated control of all of the systems. Ferrari's active aerodynamics is configured to maximize downforce. The rear spoiler rises, the flaps on the rear diffuser rise, the guide vane on the underbody closes, the flaps on the front diffusers close. The hybrid system goes into regenerative braking mode, which guarantees that the batteries are recharged even under very hard braking with the ABS active. The brakes sport new calipers specifically designed to boost cooling and to incorporate new pads made from even tougher and more durable carbon ceramic material. This technology improves the friction of the braking surface of the discs and improves consistency and fade resistance. All of this leads, for instance, to a 30-meter reduction in stopping distances from 200 to 0 km/h. Thanks to the integration of the dynamic control systems, the active aerodynamics and mechanical setup, when turning into a corner, steering wheel response time increases by 30%. When the car is cornering, lateral acceleration increases by 20% and, as a result, so does its speed. The presence of an active aerodynamic system that generates high levels of downforce means that 20mm wider front tires than those of the Enso could be adopted to boost lateral acceleration and thus cornering speed. Exiting the corner is where all of the onboard control systems come to the fore, translating LaFerrari's considerable potential into blistering performance. The high KERS and traction control play a pivotal role. Before acceleration, the high KERS keeps the V12's revs high to ensure quicker response. During acceleration, the traction control system constantly controls and distributes torque to the driven wheels. The high KERS recharges the batteries when there is excess engine torque and delivers extra torque to the wheels when required. All of this happens in synergy with both the electronic differential, which maximizes traction, and the stability control system, which monitors the car's reactions. The car is also equipped with a new virtual race engineer, with additional new telemetry features to provide the driver with extremely specific and useful information. Thanks to a myriad innovations across the board in its design and construction, the F-150 delivers absolutely exceptional performance, significantly improving on even the legendary Enso's achievements.